Good afternoon, and welcome to Lesson 9.4. As always, we have one problem-solving lesson in each chapter, and this is the one for Chapter 9. And this one fits really nicely with what we've been working on. So we've been basically talking about all this geometric stuff. And so what we're going to do is we're going to do a problem-solving strategy that basically involves drawing diagrams and is basically a geometric thing. In fact, not only is it going to be to draw a diagram to kind of work through the problem, but the problem itself is going to be a geometry problem. So let's take an example problem like this one written in red about how many diagonals do different polygons have. All right, so first let's talk about what diagonals are. Diagonal is nothing more than a line that cuts across a polygon. So for instance, if I draw a rectangle, okay, the diagonals are the lines that cut from corner to corner. They cut across the polygon. Okay, and if you think about it for a second, triangles don't have diagonals because there's only three vertices, and so if I start at a vertex right here, okay, and I try to go to one of the other two vertices, I'll go right down one of the sides. I don't cut across the figure. But if I have any kind of quadrilateral, I will have two diagonals. Okay, so in terms of answering this question, triangles look like they have zero diagonals. It looks like that rectangles have two. Let's go up to the next, or actually any quadrilateral. Let's go up to the next figure, which would be a pentagon, and let's look at how many diagonals a pentagon has. So again, let's start at one vertex. We can't draw a diagonal to either of these vertices because they're adjacent, and so we already have a line segment that connects to those. So what we can do is we can draw across to this one and across to this one. If I rotate around to this vertex, I can draw a diagonal over to here and over to here. So far I've got four diagonals. Now rotate to this vertex. Well, I already have a red diagonal going to the top vertex, but I can go ahead and draw, oops, that was supposed to be in yellow. Let me redo that, draw that. Okay, we can draw this one. And if I add up all of those, it makes a nice pretty star, but there's two red ones, two blue ones, and a yellow one, for a total of 5. All right? So, what we can do when we're trying to figure out this problem is we can actually just, literally draw an example. So let's go ahead and make a chart of what we found out so far. Okay, and what we're going to do is we're going to talk about the number of sides, and so for a three-sided polygon, and we're going to figure out the number of diagonals. Okay, and so for a three-sided polygon, a triangle, there were 0 diagonals. For a four-sided polygon, in any kind of quadrilateral, we saw that there were 2 diagonals. For a five-sided polygon, it looks like there are 5 diagonals. And finally, let's do one more diagram for a hexagon. So let's go ahead and draw a hexagon here. Okay, and again, let's color code it. We'll start with one vertex up here, and I can draw in now 3 diagonals from that vertex. Go to the next vertex, and again, I can draw 3 diagonals. When I get to the next vertex, I've already got one drawn in, but I can draw 2 more. And then when I get to the next vertex, it already has a red one and a blue one, so that takes care of 2 of the diagonals, but I can draw 1 more in. And then finally, when I get to this next vertex right here, or the vertex that follows it, there are already 3 diagonals drawn in, and they go to all of the opposite 3 vertices that are not adjacent. So let's count them all up. So we have 3 red, we have 3 blue, we have 2 yellow, and we have 1 final black one. So if I add all that up, it's going to add up to 9 diagonals. And you might notice a pattern here. Okay? So by drawing a diagram, we can kind of figure out this problem, but now we can also look for a pattern. Right here I went up by 2. Right here I went up by 3. And right up here I went up by 4. So it stands to reason if I did a heptagon with 7 sides, I would probably go up by 5. And so I'd expect it to have 14 diagonals. Alright, so let's go ahead and try that out, and we'll see if it works. And so continue with this. Let's do a heptagon. What I like to draw when I draw a heptagon is I draw a hexagon first, but then I give it an extra floor. And let's count 1, 2, 3, 4, 5, 6, 7. So there we go. And once again, if I start with the top vertex, I'm going to start in black this time. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then finally, let's use white here, we haven't used that yet, 14. And that's exactly what we expected. We expected 14 diagonals. Okay, and so extending that pattern that we saw, it looks like if we go, and the original question in your textbook is how many diagonals does an octagon have? So I think the next step is going to be to add 6, so it should be 20 diagonals. And there are lots of different ways that you can draw diagrams to solve problems. And this one happened to be about geometry, so it's kind of a very logical thing to draw a diagram to solve the question. But sometimes we'll have other kinds of word problems about, finishing a race and trying to figure out what order people came in, where drawing a diagram will really help. A lot of problems where we're maybe making a fence around a field or a portion of a field, or just any kind of geometric type thing, very often, if we draw a diagram of the situation, and maybe even simplify it a little bit too, like we did here, we can usually figure out what's going on and then work our way forwards and find a solution. So geometry is really a very useful tool to solve problems, so we're going to practice using that in class, and that's basically the video. So thanks for watching, and we will continue with this in class tomorrow. Have a good night, and I will see you in class. Goodbye.